Okay, today we're going to do a whole lot of talking and not a whole lot of doing. This is an update on the design of the mid engine car, but also how I'm designing the car and my design process. Let's get into it. Two things that we got to get out of the way before I jump into the design process itself and all those tools and things that I use. The first one is a disclaimer, and what I'm disclaiming is that this is my process of doing things. It may not be your process. It's not going to be a process that a large corporation or a large company would use to design a vehicle, and it might not be the way that somebody would fabricate a vehicle in their own shop. And all that's to say that nobody's really right, nobody's really wrong. It's just what works for you. So this is what works for me. Feel free to learn from it, feel free to use some of it, but understand that not everybody's going to tackle this the same way. Now the second thing is that if you are going to learn from this, I want to do a little bit of credentializing about myself and where I had the chance to develop these techniques. If you haven't guessed, I'm a mechanical design engineer. I have been one for the last 10 years in the off-road equipment industry. The first 5 of those years, I designed attachment for off-road vehicles, and then the last 5 years, I've actually designed off-road vehicles themselves. So I work with a small single-digit team, so the techniques that I've had to develop with that team ultimately work really well if you're the only person designing a vehicle, and they also work really well in small teams to get big things done. So with all that out of the way, let's finally get into it. To design my vehicle, I'm employing something called top-down design. Now, top-down design is an approach to vehicle development or large project development that is effectively the exact opposite of how you start learning CAD. When you start learning CAD, they oftentimes teach you to design a small part, then you take that small part and you design another small part, and you put those two small parts together, and that's your little assembly. And you might have another assembly that you bring together, and then you have a bigger assembly, and bigger and bigger and bigger until you make something large. Top-down design is that, but kind of flipped over, where you do a tremendous amount of research and thinking and planning, and you start with an empty framework of your design, and you start with the top assembly. This is your main assembly, and you have top levels within that main assembly, but that main assembly is blank, and it starts out blank, and you start populating it with parts and components. I'll get into more of that a little bit later, but before you can even get to the CAD side of things, we've got to talk about the tools that allow you to employ top-down design. So the first of those tools, and the most important in my opinion, is organization. And it can't be overstated enough how important organization is to a project of this size. Obviously, it's good to stay organized in the shop itself, where I'm putting components and things like that. But it's also good to stay organized in your design plan. It's good to stay organized in your global coordinate system. It's also really important to stay organized or have an organizational plan for naming files. If you've ever made anything out of steel, you've probably made a gusset. And after that gusset, you probably made a second gusset, and you might have called it gusset 2 and gusset 3 after that, and gusset 4. And then fortunately, you end up with a dozen gussets, you forget what they do or where they went, and you don't ever use them again. And so having a plan to organize said gussets or name said gussets in a way that allows you to know exactly what you're looking at when you see it is really important. And if you're working with a small team, it's really important to know that my gusset whatever is not that person's gusset whatever. So that's just a little note on file or part naming convention. The other organizational thing is reference features in SolidWorks or in whatever CAD system you're using. Plane 1 in this file might not be plane 1 in this file, might be plane 3 in this system. And that's called reference-based design, which is another tool we'll get to in a little bit. But it's important to have cohesive naming structure across your entire design. And that goes back right into the organizational side of things. And just as a side note, it's good to organize all the research and all the things that you do when designing a vehicle or anything else like that. There's a lot of math that's involved. There's a lot of planning that's involved. And so it's good to stay organized across the board. So again, organization, the number one tool that you need to get top-down design to work well. and something that you have to rigorously stick to. Now, the second tool that you need to understand before jumping into top-down design is something called reference-based design and/or parametric design, I've heard it called. Reference-based design is a way of using geometric references, being planes, let's say sketches, axes, points, things like that, kind of more conceptual geometry, to then develop components and place them in an assembly. Okay, so if you take a pipe, let's say you needed a pipe that was 10 inches long, you had a plane here and a plane here, and the gap is 10 inches. Well, I can extrude a pipe, I can draw a pipe on this plane, and I can extrude it 10 inches to this plane. But if this plane moves, I have to go back into that part file and then make it adjust to whatever that move. Let's say 10 inches open up to 12 inches, and I need to close up that gap. Well, I've got to go back to that extrusion, and I need to make it 12 inches now. But there's a way that I can extrude that pipe from this plane to this plane, so that whenever these two planes move, then that pipe automatically scales with it. It sounds really simple in execution, but in practice, it can get really complex. And kind of referencing the first tool, organization, it's good to have an organized plan for your reference-based design and the rules of how you reference things across certain files. So again, with the naming convention, let's say this is my lateral plane and this is my left side of the vehicle. I want to make sure that this is always my lateral plane, mid-plane, and I want to make sure this is always my left side of the vehicle. I want those two planes to always be named the same across every single file that they exist in. And I'm going to build those planes off of other planes as kind of a network. And that network building is even something that you have to keep track of and organize in reference-based design. One of the questions you have to kind of think about is, do you open up reference-based design to many files, or do you keep it on a singular path where a part will reference a weldment, that weldment or assembly will reference another assembly, or you can have that part reference several assemblies. That's kind of one of the things that you have to keep in mind and decide upon early on before you tackle a project like this and before you use top-down design. If you're working with a team, it's a good idea to have meetings and conversations about how to structure these things, because it's important that everybody's on the same page and they use reference-based design the same way. Because full disclosure, I tell a ton of people to not use reference-based design, not because it's not a great tool, but because their organization isn't at the level that it needs to be to make reference-based design successful. It's one of the hardest tools to chase breadcrumbs in SOLIDWORKS to figure out, or any CAD system, to figure out what somebody did and how to edit it later on, including yourself. And all of that brings us to tool number 3, which is the software itself. Now, clearly I use SOLIDWORKS, but I don't think it's better or any worse than any other CAD system out there. It's just the one that I've been using for over 15 years at this point. Whichever CAD system you pick, it's important to understand the fundamentals of how reference geometry works. It's important to understand references across files and the rules of engagement there. So again, not important which one to pick, but it is important to have that understanding, and that will allow you to create the organizational rules to then employ top-down design to the vehicle that you're designing. All right, so I've covered top-down design and I've covered some tools to make top-down design actually work. Now let's cover how I'm designing my mid-engine car. So things start in a top-down design as a blank assembly file, right? That's the very peak of our top-down design. And the very first file that I put into this blank assembly is a part file that I call my root file. Now, I'm gonna touch on more of the root file later. It's one of the most important parts of the entire process. So then after that, I know from my organization that I've planned out for the top-down design, I know that I have certain subsystems of the vehicle that I want to create subassemblies for that will go into this. And I'll call these my top layer or my top level assemblies. Now these sub-assemblies or these top level assemblies, they don't have to be just singular components. They can also be systems. What I typically do is I'll look at the vehicle and I say, what's primary components or what's primary systems or components, and what's secondary systems or components. Primary are things that actually drive the shape of the chassis or the shape of the vehicle. The engine, the transmission, these are almost always primary components in any kind of vehicle. And again, it doesn't have to be just a component like that. It can be a system. For example, the suspension system. The suspension is my handling goals, my layout, the chassis shape is highly dictated on the suspension layout. So that is a primary system or primary component, so it's definitely part of this root file. So what I do is I establish my vehicle geometry, my critical component locations in this root file system. Then I treat this root file as a template for this vehicle. If I design another vehicle, I take that and I just employ different parameters to it, and then it becomes a new template for something else. And every time I design a new style of vehicle, I create another template to create a vehicle off of. What I've been showing you this whole time is one of the templates that I start a vehicle with, but that's not exactly where my mid-engine car is at right now. So let's go ahead and show you how my root file looks right now. This root file has been massively modified to incorporate all of the chassis geometry into it, all the core chassis geometry. This is, again, one of those areas where there's a lot of different ways to approach this. I could have created another part file that drives a lot of chassis geometry, but I chose to just modify my root part that contains sheet metal kind of driving 3D sketches that then shape my chassis. And the reason for that is that all my core geometry lived in this root file, and the chassis is a core component, and that core geometry feeds directly off of the suspension geometry as well as the ergonomics and things like that. So it made sense to kind of create sections of the chassis and kind of the root of the chassis itself into this core file as well. And this is a good example of being able to modify your system as you go on. Now that we've kind of covered all the top-down design and the overall vehicle design approach and my plan and what I'm doing, let's go over where the vehicle is currently at in the design process. This is how my mid-engine car is currently looking. So it's a little bit choppy. You can definitely see some areas that I'm still concepting out, things I need to trim. So let's go ahead and cover this thing from front to back. Up here, I've got this kind of a plane that you can kind of envision there. That's going to be my front bulkhead plane. I have the front section of the chassis boxed out. I have my front left and my front right kind of suspension support. What I've been able to do is kind of take this suspension support, wrap it around this inner lower control arm joint, and then kind of swing it around to kind of help create that driver envelope. You can see I've got my wheel bearings all picked out. Those are actual models, or those are models I've created based on the ones that I have on the shelf already. Same thing with my upper and lower ball joints. And then I have all my bushings already selected. I've got my inboard handling bushing, I've got my ride bushing over there, and then I've got my upper control arm bushings as well. And I have started a concept for one of the lower control arms, although it needs a lot of work to go before it reaches any kind of finalized point. That's kind of the theme across the entire thing, is that there's a lot of work to go before reaching those points. But I do have the front section of the chassis. I'm concepting out some features like this. These are little basically strength modifiers for this section. It allows me to box out this section of the chassis, and I can grow them in either direction as well as thickness. So it's a kind of a tool that I can use to help create structure and then change it as needed for the front part of the chassis. I have my steering rack. This is the actual steering rack. I've got it on the shelf as well. So I've created a model for that. And obviously there's holes I'm going to cut in a tremendous amount of the body work that's been done, or the chassis work that's been done rather. Coming around to the inside of the car, I just 3D scanned this seat that I've planned on using. I'm gonna make a whole video about that, specifically the ergonomics and how I'm going to do an ergonomic study with that seat and the steering setup. I'm still working out the positioning of it, the positioning of the steering wheel. The seat's going to be adjustable to begin, and I might move to a fixed system later on. So you can see I've got my seat slides in there. Yeah, so I've got these boxed out sections on the outer sides of the car to kind of create a lot of structure there. That's gonna be a major structural component of the car. I do have a roof, but this roof is really early in development as well. I need to box it out a bit more and then kind of incorporate my firewall. I've got my engine back here. Right now I've currently hidden the 8-in-1 header collector. It's not looking great, like I'm going to be able to package that thing in too well, but it doesn't bother me too much. I am going to run the engine on the engine stand. Again, that's gonna be a whole nother video coming up. So we're gonna hear what that exhaust sounds like, and it's gonna be fun and exciting to see that go. But I will be doing another custom exhaust system to kind of package it in the car a lot easier. But similarly to the front of the car, I have these rear channel or rear chassis supports. They kind of go around the suspension geometry. They come in and then they form the inside of my box structure that basically boxes out the inside of the car. So I have these kind of longer uniform pieces, but I have run out in both directions that I'll be able to play with. I do have a lot of edge connections for the sheet metal, that's going to be a little bit tricky to nail on the manufacturing side of things. So I might play with it a little bit more, open it up, and then create some overlap in some areas. That way we can account for some misalignment during the manufacturing process. Yeah, so that's pretty much it as the car currently sits. From a part standpoint, it does look pretty simple, but again, going back to that root file and actually seeing what drives this, you can see there's all the sketches that are actually creating all of this envelope. And then furthermore, you can see all the planes that really create the layout for all of this critical thing. So I'm getting close to having all those critical components placed. It is taking some time to get them, because my procedure is to develop what I can, reach a point where I need to do a deep dive into selecting some new component. I select that component, I get it ordered, it comes in, I create a model of it, I incorporate it into the model of into the design of the vehicle, and then on to the next one. With the review of the assembly completed, I'd like to jump into a little bit more about how the root file actually works and how I incorporate that into the design process, especially for the sheet metal components that make the chassis. So when I was bringing these models in, or these subsystems in, you might have noticed that I just made everything to the origin, and that's because all of these components share the same origin. They all have the lateral plane on this one is also the lateral mid plane on this one. The ground plane is also the ground plane here. That's in the chassis. If I go to wheels and tires, which is actually blank, I have the wheels on the shelf outside. I just got to model them up and get them in there. But if I go to the steering system and I click ground plane is also ground plane. It was a little bit smaller, but it's the exact same. That seems pretty straightforward. Where I bring in something, everything shares that same geometry. And then I use this root file. It's called a root file because it bridges that geometry across all of these files here. So the chassis references its positioning and its components off of the geometry present in the root file. And let me turn on the sketches so we can see some of that. The suspension places components based on the geometry that's defined in the root file. So I do a lot of reference-based design in this top-level assembly in all of these subsystems, or these top-level assemblies, so that I can have everything be one cohesive system and bridge a gap between subsystems. If I open up suspension, like you can see, let me open up suspension really quick, you'll be able to see it's a floating assortment of parts. I have some assembly reference features that I've pulled over, but these reference features, they're pulled directly out of the root file. So the chassis is a little bit special. I'll go over that one also. Similarly to the top level assembly, how I bring files in, I made it to the origin. I do the exact same thing with these sheet metal components. All of these are mated to the origin. They are not actually touching each other or mated to each other in any way. They are all mated to the origin. So if I go over here and I click this is my front left suspension support. It's kind of catches the front suspension, then it wraps around and it helps form out the driver compartment. So this part, if I open it up specifically, it has a 3D sketch in the lower side, a 3D sketch in the upper side that create this surface loft. And if I roll it back, you can see that's what that surface looks like. Let me roll it all the way back down and we'll go look at where that comes from. If I go into my root file and I go down here to chassis development, chassis front, you can see that this solid line down here that my mouse is tracing, that's the lower side of that plate or sheet metal. And then I have this upper line as well that chases the upper side of that. So I've got my lower and my upper boundaries. Then I convert it to a loft. From a loft, I convert it to sheet metal. Back in the main assembly, I've got my newly formed sheet metal part, and let's say I need to make a cut in the side of it. Well, I do just that. But at that layer, I go ahead and I will, let me hide this sketch so we can see a little bit better. So at that layer, I will create this sketch that's based on this piece part that will now cut a hole in this piece of sheet metal. That's how the majority of these suspension components are drawn. They're drawn using those 3D sketches from the root file that then turn these into sheet metal components, or at least surfaces maybe first, then sheet metal components, and they're all done in reference to each other. You might be asking yourself why? Why do all of this top-down design? Why take all the time to develop this system and these structures and things like that? And the reason is for rapid design change and new part implementation. And so that's a fancy way of saying I can change things really, really, really fast with everything set up in reference like this. as opposed to having it not set up that way. So as a quick example, let's look at where the kind of the end of the seat right here, and then I've got this bend in the floor. You can see the spacing right here. So if I go over to my root file and I open up the 3D sketch that controls that ergonomic kind of entrance area, it's at 20 inches. Let's say I drop it down to 10, make it 15 instead. Okay, I'll exit that 3D sketch and then I jump over here back to my main assembly, and the part's updated, and this incline is now much closer to the seat than it was. And I can do it 5 more inches and you'll see that it's moved back even further. It's almost in the seat now. Now something I was unhappy over here with the chassis front. I'm guessing I lost a bit of an edge of a 3D sketch right there. That's no big deal, that's for the trimming purpose stuff. But I was able to update 1 dimension, and I had the cutout of 1, 2, 3, 4 plates, or 4 pieces of sheet metal simultaneously changed, so that cutout geometry changed across all of those. And I also had the incline or the bend angle between this plane and this plane change as well. With the root file editing, I can implement design changes that massively shape the vehicle across all the components on the fly. And I know right now I don't have a whole lot modeled, but eventually I'm going to have more structural components on the interior of the car. I'm going to have harnesses, I'm going to route hoses, I'm going to develop other structure for the steering column and things like that. And all of those components can be stretched, shaped, molded to fit the vehicle as it's developed, and I can have everything change on the fly, as opposed to all the time it would take to kind of go through all those different steps. And as one more example, I'll go to a side profile of the car. So right now I've got a wheelbase of 104 inches. If I open up this, now I could edit that part file in the main assembly, but I just choose to kind of bounce back and forth a little bit and give SOLIDWORKS a second to update. Again, I've got this wheelbase of 104 inches. Let's say I jump this up to 110. Give it a second to update, because it's updating right now just about everything. And you can see I've got a vehicle that's an extra 6 inches longer. So changing the wheelbase, which is the very beginning of the root file, I have changed effectively every component on the car. All the sheet metal parameters, they've stretched or grown in one way or another. That's why it took it a little bit longer to rebuild, but you can see that everything has been updated just on the fly from changing 1 dimension. Kind of really illustrating the power of reference-based design and the top-down design process. If you've made it this far in the video, you are a freaking trooper. This information is not easy to digest, and I don't know if it's interesting. But if you did find it interesting or you have other questions, feel free to comment below. I always like to kind of know the people that are watching these videos and kind of build a little community around that. The next video is going to be a completely different project, but it's kind of a start to finish kind of thing. Lots more fabrication and machining in that one. The Miniature car is going to be back with some ergonomic work, especially around the seat, steering, kind of positioning, things like that. So that's it. Thank you so much for hanging out. It's been fun. Catch you on the next one.